Ever get that feeling like you're trying to wrap your head around something really complex, but time's just not on your side? You want the key takeaways, the big aha moments, but without, getting bogged down in all the nitty-gritty details.
Absolutely, yeah.
That's exactly what we're doing today. We're going a deep dive into scalability testing in software engineering, giving you, the listener, that informed edge efficiently.
Precisely. Yeah, we've gone through and kind of sifted through some excellent material that really breaks it all down, the essence of scalability testing. What it is, why it matters, what exactly gets tested, how it's done, and an important distinction, how it's different from something called load testing.
Okay, so our mission today, very clear, very important. What is scalability testing? Why is it absolutely crucial for any system that wants to grow? And what are the key elements that make it work? So let's just jump right in. What is scalability testing?
So at its core, scalability testing is a type of non-functional testing. Now, what that means is instead of checking if the software does what it's supposed to, like in terms of features, we're checking how well it performs as demands change. Basically, it measures a system's performance, could be a network, a software application, even hardware as the volume of requests, from users goes up or down.
So like how it handles increases and decreases in pressure?
Yeah, exactly. You want to make sure that it can handle the growth that you expect. And that growth could be the number of users hitting your website or app, the amount of data that's being processed, how many transactions are happening, things like that. And you might hear it called performance testing too, especially when you're talking about those really big systems or when you're testing with a really huge load.
So the big picture is we're trying to find out at what point things start to break down.
That's a key insight, yeah. We want to pinpoint when an application stops scaling well, and then importantly, figure out why. What's the bottleneck? Is it the database? Is it the server? Is it the network? For example, you often see, like databases, they can start to become a bottleneck as the data grows. And that might lead to, exploring different strategies like sharding the database or using caching. Those are insights you get directly from doing scalability testing.
Makes sense. So why should you, the listener, care about all of this? How are scalability testing relevant to, everyday life?
Well, think about it this way. Have you ever been on a website and it just grinds to a halt during, peak hours? Or, maybe an app that gets super sluggish as you start adding more data to it? That's usually a sign that they haven't paid enough attention to scalability. Understanding scalability testing gives you this insight into how developers and engineers are working to prevent those frustrating situations.
Oh, yeah, that moment when everything just freezes up.
Exactly. And, scalability testing can reveal some really important things. For example, it can tell you the absolute maximum number of users that a web application can handle before the performance just tanks. It can also help you figure out if the user experience is getting worse, like are the pages taking forever to load when the system's under pressure. And very importantly, it assesses how robust the servers and infrastructure are. Where are the potential weak points? Where could things start to fall apart?
So it's looking at both sides of the coin, how the user experiences it and how the underlying infrastructure is actually behaving. So when they run these tests, what parts of the system are they looking at? What are those metrics?
There's a pretty comprehensive set of things they track. One of the most basic is response time. That's the delay between a user, clicking something or doing something and the system actually responding. Then there's screen transition speed, like how fast the application moves between different screens or pages. And then, of course, throughput. That's often measured as requests per second or transactions per second or hits per second. It kind of depends on the system. Think of a request per second as like how many clicks or actions the website server can handle every single second. So like if that number is really low when the website's under a lot of stress, that's, not a good sign.
So basically a measure of how much work the system can get done in a given time.
Precisely. And they also keep tabs on various time-related metrics, things like how long user sessions last, how long it takes for the system to reboot, even printing times, how long it takes to complete a transaction, the execution time for tasks, all that kind of stuff. And naturally, they measure performance with different numbers of users. That's how you directly see how the system responds as the load increases. And then you've got things like network usage, how much of the record bandwidth is being used, how much CPU and memory the servers are using. If those are really high, that might be a sign that the system's close to its limit. And they'll also look at the performance of the web server itself, how quickly it can handle requests and send back responses. It's a pretty thorough examination.
So it sounds like they really put these systems through the ringer. If someone wants to do this kind of testing, What are some of the essentials they need to have in place? What's the strategy? And what about prerequisites?
Well, the strategy is not going to be the same for every application. It really depends on the type of application you're testing. Like you mentioned earlier, databases, those are often a big focus, especially how they handle increasing amounts of data as the user base grows. Compare that to, say, a media streaming service. There, the strategy might be all about network bandwidth and how efficiently they can deliver content when a ton of people are trying to watch at the same time.
So a different kind of stress test for a different system.
Exactly. Now, as for prerequisites, there are several important ones. First off, you need load distribution capability. The testing tools have to be able to generate simulated user activity from multiple machines. And those have to be controlled centrally. It's like, you can't just run a huge test actively from a single laptop. You need to make sure the operating system is compatible too. Like, can the software agents that are generating the load and the central controller, can those actually run on your infrastructure? And then, of course, there are processor requirements and memory requirements, both for the virtual users, that's the software mimicking actual users, and for the master controller. You need enough horsepower and RAM to really stress the system without the testing setup itself becoming a bottleneck.
So you're basically testing the testers. So let's say you've got all the prerequisites sorted out. What's the actual process of conducting scalability testing? How does it work?
It's a pretty standardized process, which is important for consistency. First, you've got to define that repeatable process itself. So you need a consistent methodology, like a set of rules for how you're going to run these tests every time. Then you got to figure out your specific criteria for scalability. What are your target performance levels? Like, as the number of users goes up, how much performance drop are you willing to accept before you consider it a problem? Then you got to choose your tools. There are tons of software tools out there for running load tests, all with different capabilities. After that, it's time to set up the testing environment. And ideally, this should be as close to your real production environment as possible so you get accurate results.
Testing in a real-world scenario.
Exactly. Then comes the planning stage. You got to plan out your test scenarios, the specific scalability tests you're going to run. So think about the different ways users interact with your application and how you want to simulate that increasing load. And from there, you actually create these things called visual scripts. It's like a way to visually map out and automate those user actions. So you can have lots of virtual users doing them at the same time. You also got to create and verify the actual load test scenarios themselves. Like, how many virtual users will there be? How long will the test run? How will they interact with the system? And finally, you run the tests, analyze the results, see if you're meeting your criteria, and then you generate those reports.
So very systematic and methodical. I remember we talked about the importance of a scalability test plan. What makes a good one?
A really good test plan is super important because it ensures that your tests are actually answering the questions you need to answer, that they align with what the application needs to achieve, and with your overall scalability goals. There's some key things that make a test plan really solid. Number one, it's got to have detailed steps for those scripts we talked about, like exactly what actions will the simulated user perform. That level of detail makes sure your tests are consistent and repeatable. Second, it needs to identify any runtime data. That's data that the test will need to use while it's running, like login credentials or specific input values for transactions. And finally, for data-driven tests, you need to list out all the fields that'll need different data each time the test runs. That way, you're simulating a wider range of user behavior, making it more realistic.
So not just throwing a bunch of virtual users at the system, but making them act like real people would. Now, there's another term that comes up a lot, load testing. Our material mentioned that too. Could you clarify the difference between scalability testing and load testing?
Yeah, that's an important distinction. They're related, for sure, and often used together, but they have different primary goals. Load testing, at its heart, is about seeing how an application behaves under a heavy load, like really pushing it to see when the response time becomes unacceptably slow or the system just completely fails, finding its absolute limit right now.
So figuring out its current capacity.
Exactly. Scalability testing, on the other hand, looks at how well the system performs as you change its size or volume to meet growing needs. So it's not just about finding the breaking point under a static load, it's about understanding how the system adapts and maintains its performance as it scales up and sometimes even down.
Okay, so load testing is more about pushing the system to its limit now, And scalability testing is about understanding how it will adapt to changes in demand over time.
You got it. Scalability testing is about whether the underlying architecture can handle that growth. Like if you add more servers, will performance improve proportionally? Or are there other bottlenecks that will pop up? Load testing is more about how much can this system handle right this second.
Okay, so putting it all together, what's the big takeaway about scalability testing from our deep dive?
The bottom line is this. Scalability testing is crucial for understanding how well a system can adapt to growing demands. More users, more data, more transactions, whatever it is. It's about finding that point where the system starts to struggle to scale and making sure that it can keep performing well as it grows in the future.
And it's not just a one-size-fits-all approach. As we've been discussing, it really needs to be tailored to the specifics of the application.
Exactly. You got to consider things like the architecture, how it connects to other systems, and how it's expected to grow. All of that goes into designing and running effective scalability tests.
So listeners, next time you're using an app or website, especially one that's really popular or experiences sudden surges in traffic, think about all the work that goes into making sure it can handle that demand. Remember these principles of scalability testing. Ask yourself, how well does this system seem to scale? Where might its breaking point be? Understanding scalability isn't just for tech people. It gives you a deeper appreciation for the technology we all use every day. It helps you see the complexities involved in building systems that can grow with us as our needs and expectations evolve.
That's a really good point. And it highlights how scalability testing is all about being proactive, anticipating future demands, and making sure that systems are designed not just for today, but for long-term performance and growth.
That's all the time we have for today. Thanks for listening.
Thanks for having me.